Good afternoon. This is Robot in 3 Days brought to you by Full Moon Robotics. Welcome to our final presentation.
The 72 hours has just finished, and it's time to reveal the robot. But first, we need to say thank you.
Thank you for tuning in over the past 3 days. Viewers, your support is much appreciated, and we hope you've enjoyed the event.
In addition, we'd like to thank our sponsors. Thank you, Relay, for providing the devices that helped make this hybrid event possible. All of our in-person team members are wearing Relay devices, which allow them to communicate with the virtual team in real time.
We would also like to thank NC State Entrepreneurship for allowing us to use their prototyping garage space for this event. They've supported us the past 2 years, and without them, this event would not have been possible.
And lastly, thank you, Team 435, the RoboDogs from Raleigh, North Carolina. The RoboDogs graciously allowed our team to use their build space all weekend. Due to COVID-19 and the current statewide restrictions, we needed multiple locations to keep our team members safe. We utilized their space to build and manufacture our power cell shooting mechanism that you will see today.
Again, thank you, sponsors. You are what makes this event possible. Now, the moment you all have been waiting for, it's time to talk to the team and show off the robot. Let's start by talking to Kevin.
Hey,
Hello,
Kevin,
everyone.
how are you doing?
I'm doing pretty good. How are you?
Excellent. All right, so it's been a long 3 days, and you've done a lot of work. So,
can you walk us through your engineering process over those past 3 days?
Yeah, definitely. I'll, if it's cool, I'll share my screen real quick so you guys can see. Oops, that's my video. Well, looks like screen sharing is disabled at the moment, but I'll talk you through it. So over the past 3 days, I've had the unique challenge of CADing a robot while being at home. And since this is my first year on the team, I've never actually gotten the chance to see this robot in person. And there we go, screen share is working now. So I had to piece together the robot, basically working with images online and that the team sent me, and then working with the in-person team to get dimensions to build the robot, as well as developing new parts here in CAD and then sending those dimensions over. So I'll walk you through the robot a little bit. So this right here is the overall structure of the robot. As you can see, you've got the main chassis drivetrain, you've got the intake right here, and we've got the ravine and the shooter. And this was one of the things I was saving for the special reveal right now. Earlier today, I spent some time modeling this beautiful bumper with our logo on it, just to give it that extra level of flair.
That's excellent. I love it.
Yep. So a little bit about the CAD. So as you can tell, it's still a little bit bare bones. During the process, what's missing on this model right now, as you can tell, is the electronics board, as well as any fasteners. And then the one major component that's still missing is the structural support for the shooter itself. And the reason behind that is I am waiting for the dimensions from the in-person team. They had a lot of work to do today, so I didn't want to get in their way. So that's the last thing we're waiting for, the main structural stuff. And then I've had to forego the electronics board and fasteners, partially due to time constraints since it was such a short time working on this. And also my computer was starting to struggle a little bit with the sheer amount of parts in there. So on the list for next year is a new computer for me. Yep. And then like I was talking about earlier, I had 3 different engineering processes I had to take, which was an interesting challenge working at home. So since we were redesigning the robot from last year, the first thing I had to do was reverse engineer the robot, like I mentioned, using pictures and working with the team in person. So that was one of the aspects. I had to basically reverse engineer the entire drivetrain portion. But when it came time to do the shooter, which I just pulled up right here, that was something we were developing new for this season. So I worked in conjunction, in parallel with the in-person team at the RoboDogs workspace, and we were on call discussing dimensions, trying stuff out in CAD and in real life at the same time to design this shooter that we're using on the robot. And then the third process I had was with the ravine. And this was particularly fun, let's say. So This was something that I designed from scratch purely in CAD, because once I had the chassis CADed and the motors and everything in place, I now had a set of constraints to work with, and it was easiest to put it all in CAD and figure out what angles and dimensions all work. So I spent a long time developing this in CAD, doing a bunch of 3D sketching, as I showed earlier, and finally came upon this final product. I sent these dimensions over to the in-person build team earlier, and they got it built, and it's on the robot now. So yeah, overall, CADing this robot has been a pretty fun experience. I've learned a lot, and I hope people watching the stream were able to learn a lot as well.
Incredible. Wow. Yeah. Cannot thank you enough for all of the hard work you put into this and how useful your work was for our in-person build team. So thank you again, Kevin.
Absolutely. Is there anything else you'd like to share with us or anything else you'd like to say?
I will be making these CAD files public through our GrabCAD workspace, which I will share in the coming day.
Awesome.
And I'm sure you will be able to find that link on our website when he gets that posted. So let's switch over now and let's talk to our programming team. Let's hear from Trevor. Trevor, how are you doing?
Doing well.
Good, good. All right. As I said to Kevin, it's been a very long 3 days. Where'd you start and where are you now?
Well, we started with last year's code, and there were a lot of things that were not entirely optimal, and a lot of things on the robot changed. And so over the past 3 days, we've sort of taken last year's code, and most of it's been rewritten. So yeah, and it now accounts for all of the new subsystems and all of the new changes to the robot, including the shooter. We fixed some things with the control panel mechanism, and we made a whole bunch of other changes to it. We also did autonomous work. And yeah.
Excellent.
Right. As of now, we have made, 92 commits to our repository over the past 3 days and 18 pull requests.
Cool.
Wow. You guys have been working hard. We really appreciate all the work you guys have been doing.
All right. So tell me a little bit about the challenge of being virtual while working with a robot that you haven't seen before and you can't actually get your hands on.
It was definitely a challenge because I'm used to sort of getting up close while I'm developing things so I can see, like, is this motor turning the way it should, or is like this feed through the shooter working properly, which is a lot harder to do over, say, Zoom, but we made it work. And another helpful tool was that I had a virtual connection to the driver station, so I could watch the dashboard and get some information from that while we were running the robot.
I'm sure that was really helpful. What kind of information are you looking at when you're looking at the dashboard?
Well, specifically during auto, we had a lot of diagnostics, which helps with like figuring out bugs with like encoders, etc. And then we also had like gyroscope outputs, so we could tell if the gyroscope was working. But the shooter was a big one, and that we had like the current RPM measurements and error and a bunch of other things logged about the shooter that were useful for diagnosing problems.
Nice.
All right, so one more question. Speaking of autonomous, can you kind of give us a short rundown about the curve following that you worked on?
Yeah, so we basically just implemented the WPI-lib trajectory following, and essentially what it does is it estimates the robot's position relative to the start, and then it uses a pre-generated curve, and it basically looks up where the robot should be at any given time, and using encoders on the drivetrain and a gyroscope, it figures out where the robot is, or at least it attempts to estimate, and then it uses those two pieces of information to generate commands to actually drive the robot. And so it's able to stick to the path pretty well, and even if it gets knocked off the path or drifts off the path, it's able to correct and still end up where it's supposed to, or at least in the ballpark.
Nice.
That's really neat.
All right. Is there anything else you'd like to share with us about your programming team's journey these past 3 days?
Well, all of our code is open source on our GitHub page, Full Moon Robotics, and the repository is called RI3D 2021. It is licensed under GPL, so you can do whatever you want basically with our code. Just feel free to look at it. Yeah.
Awesome. And that is definitely linked on our website in our header, so you go check that out.
Well, very neat. All right. So now I think it's time to check in with Jake and Tejas, who have been on the in-person build team. Hello, how are you all?
Hello, we are doing great. How are you?
Also doing great. We're out here at the in-person space now, and I think Jake can get us started with what we've been doing.
Excellent.
Yeah, so a bit of a recap of the past 3 days and the process that's been going on the in-person and on-site sort of things. So day one, we came together and we initially took the unique challenge of this year by looking at last year's robot and figuring out if we had more time, what would we improve with it? And once we figured out the challenges from infinite recharge at home, we had to prioritize that list, considering that unlike a competition, there is no really unique advantage to having a climber or control panel mechanism for the challenges at home. And so once deciding that, and the fact that our robot from last year was a low port robot, we had to decide that we had to improve our intake, change the mechanism that got the balls from the intake to some sort of launcher, and then, as I just kind of spoiled there, switch to a high launcher. And after some general note-taking there, we came with some general brainstorming plans on each side of those mechanisms, and we split off to reconvene for the next day, except we now had the RoboDog space. And so what we did to make sure that we divided and conquered efficiently is that the RoboDog space, we worked towards getting that launcher prepared with the heavy machinery that was allowed on that site. And on this site, we worked towards improving the minor electrical issues, reinforcing the intake, and together with Kevin's amazing CAD work, especially helped bridge those two sites together with just technology, but also creating the bridge between the intake and the launcher. And that really leads us to this day, or yesterday, where we then brought everything over to the eGarage site, started mounting, and today we got into final mounting and testing.
Awesome.
So we can go into more specific things now.
Yeah, so Jake covered a lot of great things with the RoboDog site, and a lot of the parts there we just manufacture, bring over here. And I think being virtual, we kind of thought it would be pretty difficult, but overall we've managed everything pretty well. Everyone virtual has been in contact with us at all times, and especially like, you know, throwing around the CAD files too. So I can kind of go take a look at the robot now with the shooter and the hopper that we've created. So over here on the back, if I just lower the intake. Sure. On the back here is our shooter, which took a while to design. So basically what we did was our design process really early on in day one, we were kind of thinking, okay, we want to score high goal, and we want to be able to score high goal from different points on the map. So how can we accomplish that without changing too much that we already had on the robot? So we kind of came to the conclusion that a hooded shooter was probably the best idea to kind of go about that. And we immediately began prototyping, designing, sketching out different strategies to make a hooded shooter. So that's pretty much what we have right here. The shooter has two hoods on either side with multiple holes so that the wooden poles you see on the back here, they can be put into any of the holes to kind of adjust ball compression. So we have a lot of variability with this shooter. And there are three main flywheels here that kind of direct the ball through. The ball comes in from underneath, up and out the front.
Hey, just one thing real quick. One thing. I don't mean to interrupt. Can we get a closer view? Because we're looking really far away right now.
Yeah, let's see. Can you guys see the second camera?
I can see the second camera.
Okay, we can see it now on the stream. Sorry, I didn't mean to cut you off, but also we couldn't see what you were pointing at. So
All good. Awesome. So, yeah, from the second camera, pretty much the ball comes through the flywheels, comes out the front. And at first glance, I know the shooter may seem pretty simple, but there's a lot of actually math that did go into this. We had to find pretty specific dimensions for this. We had to get a couple angles, and we had to find the angle of release that the ball should have too. Now, a little underappreciated piece right here is probably these indexing wheels that we added at the front. Pretty much when the ball is sitting in the hopper like this, idly, the wheels will just slowly run backwards so that the ball won't enter the shooter. And then once it's time to shoot, we let the shooter wheel spin up to full capacity, and then the wheels will kind of push the ball underneath into the shooter. So these wheels are doing a fantastic job out here. And the last thing I want to talk about real quick before I hand it over to Jake was this hopper, which we kind of started coining the term ravine because when Kevin and I were talking about designing CAD file, the best way that we could kind of describe this was like a ravine in real life. So that's what this became really fast. And pretty much Kevin worked hand in hand with us with this. He kind of took what we'd given him in dimensions. He gave us back the exact dimensions, and we kind of cut it out of polycarb, and we put everything together, and it worked out exactly how the CAD model shows. So anyone wondering if CAD is useful? Yes, it's amazing. So yeah, the ball kind of just comes through the intake, gets caught up here, and it's completely gravity fed. So the ravine kind of rolls the ball down. And once it's on the indexer wheels, they'll send the ball through the shooter and shoot it out the back.
very nice. Can I ask you a question real quick?
Yes.
So how did you come up with the geometry for the ravine? Because, for people watching, it seems like, oh, well, I mean, you could just put a piece of plastic there and the ball's going to roll down no matter what. What specifically about that geometry? Why is it the way it is?
Yeah, it's a great question, actually. And a lot of this design, out of all the stuff that's designed here, surprisingly, the ravine was one of the things that took the longest to make. That's because with this season and how the balls are created, they tend to stick everywhere. They tend to stack on top of each other. They squish against each other. They kind of just like getting into messy situations. So we wanted to make it as smooth as possible and also never have an issue where two balls could jam side by side and not go into the shooter in a single file line. That being said, our original design was just a simple flat ramp kind of going down, gravity fed towards the shooter with two other ramps just simply going up from the side. And then quickly we realized that that would be a little bit thin. Our intake is pretty wide and we wanted a lot more space for the balls to kind of come in at a wider angle than be compressed down. So a lot of experimenting with that and talking with the CAD team led to the current design, which is a ravine that's broken in half to a bigger ravine that kind of has a large entrance. We'll just call it the hopper. But yeah, and the sloped walls are pretty essential to this. They're all sloped at exactly 120 degrees just so that the ball has no interference with other balls and we can fit three pretty perfectly. So it took a lot of planning out.
Very good, very good. I like it. So
Awesome.
I think unless there's anything else you guys want to say or talk about.
I can touch quickly on the other elements of the robot. Tejas did a really good job at talking about the ravine and the launcher, which are probably the two most unique and different elements of this robot from last year. But if you kind of look around like an I Spy puzzle, you'll start to notice that a lot of elements or parts from last year's robot kind of got stripped and then reused in different ways. Like the indexing wheel that Tejas was pointing at, that was previously used as another at the top of this robot up here to index into a low port shooter earlier last year. And some elements are still there. We just used them and repaired them, as in this control panel element right here with the piston and all the pneumatic tanks. We had to do a bit of fine tuning there. And then on the intake, it is mostly still the same, but as we talked about on the first day of our stream, there was the roller right here. I guess you can see my finger. This roller was falling out Jake. On the other end. Was that Sam?
Hold on 1 second. We can't see the intake. We're looking from the back of the robot.
Okay.
The second camera angle, you've got a pretty good shot of the intake. Can you just move the
Okay.
robot a little bit back so that we can see the whole intake? Sorry about that, Jake. Thank you.
That's fine. Yeah. So on the second camera, this
Perfect.
side of the intake, the roller was falling out. It was loose. It was not very good for what it could be. So with some specialty made parts and changes to where it was located in the frame, we were able to secure it and make it much more reliable. The drivetrain is pretty much the same, being the changeover in West Coast it is. We did have the option to make it pneumatically shift, but we opted to take that out and use the extra Neo motors for the launcher. So a lot of taking off and reusing in different ways. And it's not Recycle Rush, so do not panic.
Nice.
But I can field any questions on any of that. On the electrical stuff, small changes like the RSL was moved to a higher point, so it's not like falling off into the frame of the robot. And funny enough, the canvas wire is not over the battery anymore. So now you can have a quick change of battery without destroying your electrical wiring.
Awesome.
Hallelujah.
Excellent.
So are there any additional questions before we start getting this moving and talking about it more?
I don't think so. I think we're all just excited to see it drive, see what it can do.
Awesome. Well, as it is connecting and being prepared, we have on the wall up here, we have prepared a high port for us to be shooting in. As it says in the manual, you are able to make a 2D port. There's a lot of specifics on how to score using that. So like percentage of the ball within those areas. And I highly recommend that if you plan to use a 2D port for your shooting, that you look into those specifics to make sure you're calculating your score correct.
Yeah, and real quick before we go ahead and shoot one here, some shooter specifications. We're just running the shooter on one Neo motor, which is geared to one-to-one, and it can run at about 7,500 RPM, which is pretty good for the shots that we're trying to take right now. And so far, we've seen that the about 50-degree angle that we've created at the shooter is working out pretty well to hit the target. And hopefully, yeah, hopefully everything runs smoothly here. So we're going to go ahead and do a test shot.
Did you set the RPM correctly?
Hey, Tejas, quick question for you.
Yes, what's up?
How did you come up with that 50-degree angle? Why did you choose that?
Yeah, great question, actually. So that too took surprisingly longer than expected. Originally, we knew, I kind of knew that since we were a low hooded shooter bot, we'd need a kind of steeper angle. And the most, I guess, average or like regular angle you can pick is 45 degrees for a shooter that's shooting a ball out. And so this whole kind of shooter mechanism has drawn inspiration from other teams all around. So once I realized that most teams were kind of going with 45 degrees, 40 degrees, but they were kind of higher up shooters, we could kind of imitate that, but with 50 degrees since our shooter is pretty close to the ground. So 50 degrees also allows you to use just different flywheel speeds to get the same shot to go in from different ranges rather than actually having to change the position of the hood. So since we wanted to make this as simple as possible and still shoot from different areas all around the map without actually changing or adding like a piston or a servo or something to adjust the hood, we decided that it'd be easiest if we just mesh with the flywheel speeds, and this angle really allows for that a lot.
That's really smart. I like that.
Yep.
I think we have a test. Wow.
Very nice. Very nice.
Good teamwork there, guys.
So, is there anything you guys would like to see on stream right now?
We'll watch anything as long as it's robot related. Anything you want to show us?
There's the solid intake.
Nice.
Yep. Would you guys like to see an auto routine now? We can run one of our autonomous routines.
Make
If
sure
that
the
works for you
gyro is
guys.
set up.
All right. So yeah, from that, as you guys can tell, the intake works pretty well. There do need to be some adjustments on the hopper to extend the length forward a little bit, maybe make it easier to catch some balls. And we do need to spend a little bit more time testing the shooter, testing the indexing and everything, just so that the balls can release more consistently. But overall, considering that we kind of just built the entire shooter at another space, brought it here, and slapped it on the robot first thing, tried it out this morning, I think we're pretty happy with how it's shooting balls today.
Yeah,
Yeah,
it
absolutely.
looks great, especially for the 3 days that you had to work on it.
Like, the first time we tested it was about 5 minutes before this meeting started, so
No worries with that. I'm sure obviously the time constraint is very difficult, but I'm sure teams that are watching this, they would have more time to test than us who had very, very short amount of time. So it's the concept here works.
On the topic of things for teams to consider, one thing that you might have noticed is we were having a little issues with the intake itself. Sometimes we get stuck in the intake. So with some additional development time, that's probably one thing I would suggest teams really look out for. When designing an intake, some things to keep in mind, you want to make it as wide as possible so that you can let your drivers have an easier time of intaking power cells, but you also want to make sure you do a good job of getting those power cells into the robot and keeping them in the robot. As you can see, when we drive around, we're prone to losing some power cells.
So, Kazan, question real quick, or either one of you, what changes would you make to the intake if you could right now?
I guess I'll start off. So in my opinion, I would probably add some sort of vectored intake wheels onto the intake. That way, vectored intake wheels are basically like small Mecanum wheels, and the rollers on them let you direct the balls towards the center of the intake. And the reason those are nice is because you can approach the ball from any angle and you can keep as wide an intake as is allowed within the rules. And it'll help you center the balls, make it a lot easier to keep them under control. The next big thing I would probably change is For the intake itself, right now, once we drop it down, we have no way of bringing it back inside frame perimeter unless, the round's over and we have our drive team pull the intake back up. So I would probably add pneumatics, like a piston, to control the actuation of the arm itself, because being able to bring that back into frame perimeter means we can take some hits from robots. Right now, it's kind of hanging out and vulnerable to getting hit by other robots.
Awesome. Thank you for that insight, Kevin. Tejas, I think you have something you'd like to share.
Yeah, also about the intake. One kind of thing that we noted from last season was that normally you want the ball to be touching some sort of roller, some sort of wheel, some sort of control mechanism at all times, which is something that, we could probably improve on in the future. But yeah, normally touching some sort of thing that controls the balls at all times is kind of making sure that you always have full control over the ball and that you know what it's going to be doing. So there's no like variability. Also, with regards to design, FIRST is an amazing community. All the teams love to help each other out. So I know, like, if you look anywhere online, like Chief Delphi or other resources teams put out, it's pretty easy to find really creative and innovative ways that people kind of design mechanisms. So I think before we run this autonomous routine, could Trevor explain it really quick? What's going on?
Yeah, so basically it's going to follow a path similar to what's presented in the challenges, but not exactly, since we don't have enough space for that. But it's basically, it should just do some circles around the little bumps on the floor that you see, and if it starts spinning off to the side, that is indicative of an electrical issue. So just be prepared for that in case that happens.
Awesome. Thank you for the heads up, Trevor.
And if you want to see a video of the robot doing this more, it'll be on our YouTube channel at Full Moon Robotics. I believe that was uploaded yesterday.
All right, we're going to go ahead and send the auto off. 3, 2, 1, go. Woo! Awesome.
Awesome. Thank you, guys.
That is right. So briefly mentioned earlier the control panel mechanism on the side here. We can show that actuate and spin.
That'd be awesome.
That's actually what I was just about to ask.
And if Infinite Recharge were to have competitions in person, control panel mechanisms such as that would have increased value this year. Just as when reading the manual, you'll notice that the control panel points actually have more value this
year. Yes.
That's very interesting. One quick question for you. How is that going up and down? What kind of mechanism is that? Can we maybe get an up-close view of it?
We could. Sam, do you want to drive it over closer to you? Either camera works. So the actuation of it going up and down is from a piston on the side of it, as the motor and the wheels themselves run on a track within some channel. And so it just, once the piston actuates up, the whole system, goes up through this channel with the piston. It doesn't look like the piston's doing much, but that's because it's upside down. So the actual piston that comes out is behind the air tanks.
Awesome. Well, is there anything else on the robot you guys would like to show off?
I think we've kind of covered most parts of it. But I would like to say, definitely stay tuned. Hopefully we'll be filming a reveal video soon, and that'll be out too over the next couple days. So that'll kind of showcase, again, everything we've done in this presentation, kind of what else the robot has, hopefully with some cool music to it. So you guys can check that out on our YouTube over the next couple days. Yeah.
Well, thank you very much. We really appreciate it. You guys have worked very hard, and I think the hard work has really come through, and you can see how well the robot works. Nice work, everybody, and thank you very much. Please be sure to check out our YouTube channel, Full Moon Robotics, as well as our website, fullmoonrobotics.org. We'd also like to say a quick thank you to our sponsors, Relay. The devices that you see our in-person build team members wearing, that is allowing them to communicate with us, the virtual team, in real time and all the time. We've used that constantly, and I'm not sure this event would have been possible without those. So thank you very much to Relay, as well as Team 435, the RoboDogs, for letting us use their build space. That helped us stay within the COVID restrictions and keep our team members safe, and giving us access to the tools we needed to make this event possible. And lastly, thank you to the NC State Entrepreneurship Garage, where you can see our in-person team at right now. The garage has sponsored us for the past 2 years, allowing us to use their entire building, workshop, and garage space to do this. Without them, again, this wouldn't have been possible. And we'd like to thank everybody who's been watching at home all weekend over the past 3 days. Thank you so much. This has been Full Moon Robotics, Robot in 3 Days. Thank you.